Hi all, this video will help you to solve the convolution of two signals using graphical method. Let us consider the problem determine the convolution of the signals x of t and h of t using graphical method. In this problem, x of t and h of t both are represented graphically. X of t equal to 1 for t is equal to 0 to 1 and h of t equal to 1 for t is equal to 0 to 2. According to the formula of convolution, x of t convolution h of t equal to integral minus infinity to plus infinity x of tau h of t minus tau d tau. Here we are having x of t which is in green color, h of t which is in blue color. We need to find x of tau. X of tau can be obtained by replacing t by tau. So I am just finding x of tau, which is nothing but the x of t with the change in variable. Here I change the variable t to tau. All other things remain same. Here we are having h of t. So h of tau is same form, only the variable changes. So I am directly applying the time reversal operation and I am just finding the h of minus tau. So h of minus tau is nothing but the mirror image of h of tau, or here in this case h of t. So this is the h of minus tau. And here I need to obtain h of t minus tau. So h of t minus tau is nothing but the time shifted version of h of minus tau, and it is time shifted by t samples. Let us consider this diagram. Here we are referring the green color for x function and blue color for h function. Here I am representing this as h of t minus tau. Here the variable is tau. Here I am just shifting the signal by t samples. Here what we are doing is we are solving for the first condition, that is we are considering the value of t is lesser than 0, that is t is a negative number. So in this case, if it is a negative number, the signal h of minus tau will shift towards the left hand side. So instead of 0, it will go to the point t. Instead of minus 2, it will be again shifted by t samples, and t is a negative number because t is lesser than 0. So this will be t minus 2. So this signal is shifted towards left side since t value is lesser than 0, and it is shifted by t samples. That's why we are getting the signal like this. So this is our x of tau and this is our h of t minus tau. Then we have to overlap both the signals to find the common region. That means overlapping region. Okay. So when we are overlapping this x of tau and h of t minus tau, the resultant will be like this. So in this case, the value of x of tau and h of t minus tau will be like this. So there is no overlapping region. There is no overlapping region. So the product of x of tau and h of t minus tau equal to 0. This is nothing but the product of x of tau and h of t minus tau. So this product value is equal to 0. Why? Because we don't have any overlapping region. So first we are considering the t range. T is lesser than 0. Let us consider this as case 1. t is lesser than 0. So in this case, y of t is equal to integral minus infinity to plus infinity x of tau h of t minus tau d tau, which is equal to integral minus infinity to plus infinity 0 d tau, and that is equal to 0. It is because x of tau into h of t minus tau is equal to 0, since there is no overlapping region. We can easily understand the convolution graphical method by recalling the solar eclipse. Let us consider this green color as the moon and the blue color as the sun. So in this case, the eclipse is not happening, so there is no overlapping. So till this point the eclipse is not started, so that's why there is no common region or overlapping region. Now we found the value of y of t for t is lesser than 0, which is equal to 0. Now we need to find the value of t for t is greater. Let us consider the problem for case 2. In case 2, we will consider the value of t as greater than 0 and lesser than or equal to 1. In the previous case, we consider the value of t as lesser than 0. So here the x of t, h of t and h of minus tau remain same. There is a change in h of t minus tau, since we are considering the value of t is greater than 0 and lesser than 1. The h of t minus tau will be like this. So here in the previous case, it is in the left side of the y-axis, and now it crossed the y-axis by t second, and the value of t is lesser than 1. Now consider this overlapping region. We are just overlapping x of tau and h of t minus tau, and the resultant will be like this. And if you see the time values or tau values, you can easily identify what is happening in this. So let us consider this as your 1. Since t is lesser than or equal to 1, we are considering t is having a middle value which is around 0.5. Okay, so let us consider a rough value for t, and this value will be t minus 2. If t is equal to 0.5, this value will be minus 1.5. So this is the overlapping of x of tau and h of t minus tau. You can see the dark green color. In this case, the green color denotes x function and blue denotes the h function, and the dark color denotes the overlapping region, or else you can call it as the multiplication of x of tau and h of t minus tau. So here after few seconds or after few portion of seconds, it will be like this. Since this portion is shifted towards right hand side, the overlapping region will start to increase. Okay, and this is the case where the value of t is very closer to 1. So if you consider this case, the overlapping region will be like this. So the ending point of the overlapping region will be t, and the starting point of the overlapping region will be 1, and the amplitude of the overlapping region throughout the time period is nothing but 1. Okay, and this can consider as x of tau h of t minus tau. So according to the convolution formula, the value of x of t convolution h of t equal to integral minus infinity to plus infinity x of tau h of t minus tau d tau. Here we obtain the product and we know the limit to. The limit is 0 to t, and in this region the amplitude is 1. So instead of x of tau h of t minus tau, I replaced with 1 and d tau, and if you do integration, then this will be tau. The upper and lower limits are t and 0, and if you solve for the upper and lower limits, then you will get t minus 0, and the final value is t. This is for the case 2, which is t is greater than or equal to 0 and lesser than or equal to 1. So if you compare with the solar eclipse, then this case comes under this one. So this is the first contact phase in solar eclipse, and this is the second contact phase in solar eclipse. So what we are discussing is nothing but similar to the second contact in our solar eclipse. Let us consider the case 3. In case 3, we will consider the value of t as t is greater than or equal to 1 and lesser than or equal to 2. So x of t, h of t and h of minus tau remain same. Let us consider h of t minus tau. So h of t minus tau will take this shape. Overlap these two signals, x of tau and h of t minus tau, the resultant signal will be like this. So you can see the value of t is greater than 1 in this case. So the overlapping region is nothing but the area equal to x of tau. The entire x of tau is overlapped with h of t minus tau. Okay, so here you can see the dark green color denotes the overlapping region, and you can consider this overlapping region as x of tau into h of t minus tau, and we know the formula x of t convolution h of t equal to integral minus infinity to plus infinity x of tau h of t minus tau d tau. Here the starting point of the overlapping region is 0 and the ending point is 1 and the amplitude is equal to 1. So you can change the limit as 0 to 1, 0 to 1, and the product of x of tau and h of t minus tau equal to 1 in this region, and the integrating variable is tau, so d tau, and this can be done as tau with upper limit 1 and lower limit 0. After substituting the upper limit and lower limit 1 minus 0, the final result is equal to 1. If you consider this case to the phase of solar eclipse, then the corresponding phase is totality phase. So that is the entire moon is trying to cover the sun. Let us consider case 4. In case 4, the value of t is greater than or equal to 2 and lesser than or equal to 3. Here x of t, h of t, h of minus tau remain same. If you refer h of t minus tau, then it is nothing but time shifted version of h of minus tau towards right hand side, since t is a positive number and the value of t is greater than 2 and lesser than 3. So the starting point of h of t minus tau is t minus 2 and the ending point is t, and the amplitude is 1 throughout the region. And if you overlap x of tau and h of t minus tau, and you can see the common region which is dark green color. So here the starting point of this common region is t minus 2, and the ending point is 1. 1 since the amplitude of the common region is 1. So 1 d tau. If you integrate 1 with respect to tau, you will get tau. And if you substitute the upper limit and lower limit, then this can be simplified as upper limit as 1. So 1 minus the lower limit is t minus 2. So this is nothing but 3 minus t. If you refer this case with the solar eclipse phase, then this case comes under third and fourth contact phase of solar eclipse. And we are moving to the next case 5. Here the value of t is greater than 3. So in this case x of t, h of t and h of minus tau is same as like the previous cases, and consider h of t minus tau. So the h of t minus tau will be in the right side of the y-axis, and if you overlap x of tau and h of t minus tau, you will get this kind of thing. And here you can see there is no overlapping between the green and blue region, that is x of tau and h of t minus tau. So here if you consider the value of t is 3.5 since t is greater than 3. If this value equal to 3.5 and this value will be 1.5, so obviously there will be no overlapping. Because of no overlapping, the value of x of tau and h of t minus tau equal to 0 because no overlapping. Hence the value of x of t convolution h of t is also 0 because the product of x of tau h of t minus tau is equal to 0. Obviously the value of x of t convolution h of t is also equal to 0. Consider y of t as x of t convolution h of t, and we will summarize the result obtained for the previous 5 cases. Here case 1 is t is lesser than 0. For this case we got the convolution value as 0, and the case 2 is t is greater than or equal to 0 and lesser than or equal to 1. For this case we got the value which is equal to t. And the third case, the value of t is greater than 1 and lesser than or equal to 2. For this case we got the value of x of t convolution h of t as 1. And the fourth case is t is greater than or equal to 2 and lesser than or equal to 3. For this we got the value of x of t convolution h of t as 3 minus t. And the last case, t is greater than 3, we got the value of convolution as 0. Since they are asking you to find the convolution using graphical method, we have to represent the answer y of t, which is nothing but x of t convolution h of t in graphical form. So here the y-axis is y of t and x-axis is t. It's not tau here. And here if you see the expression of y of t equal to 0 for t is lesser than 0. So obviously nothing will available in the left side of the y-axis, and the value of y of t equal to t for t is greater than 0 and lesser than 1, lesser than or equal to 1. So which is nothing but a ramp function for the period 0 to 1. And for t is greater than or equal to 1 and lesser than or equal to 2, the value of y of t is equal to 1. So we are drawing a horizontal line from t is equal to 1 to 2, and if you check the values of y of t during the time value 2 and 3, then it is 3 minus 2. So let us consider t is equal to 2.5, then it will be 0.5. T is equal to 3 means it will be 0. So it will be like this. And for t is greater than 3, the value equal to 0, and this is the final output. That is, this is the graphical representation of the convolution of the signal x of t and h of t. Here I solved with a basic problem for better understanding of this graphical method convolution technique. Here I solved a simple problem to understand this concept in a better way. So you can apply the same concept for complex problems too. Thank you all.